started streaming. So I'm going to open Discord and put the thing on full screen. And yeah, it should work. And yeah, let's start with this. I'll briefly check that it's actually streaming on YouTube, but after that. Okay, yeah, it's streaming. So let's start. So this is a new paper by a bunch of people and Neel Nanda. I'm not sure, but I will guess maybe this is a since Neel is as the last author and like there's a bunch of people who are not from the DeepMind lab. It's probably a maths paper or something like that. Or something where Neel is a mentor, but I don't actually know. Well, Neel and Arthur Conmy. It's probably from maths.
Yeah.
So I guess that the main people doing it is Camila, Blanc, and Agam, Bhatia, or whatever that name is pronounced. But,
it has 27 likes on Alphaxif, which signals good paper alert.
I mean, I think Neel being on it is probably also a sign of a good paper usually.
That's true.
I guess he could publish a math paper at some point.
Math paper?
A math paper, I mean.
Oh yeah, okay. Yeah.
But
like this makes me wonder, like, because when you have all the different features, I wonder if this is something about that there's a direction for each, like, I don't know, preference for owls. Well, I guess they're trying to explain it in the steering wheel frame, so I guess that's what they're trying to do.
Let's go to the thing on the paper. So what is this paper about? So this is about subliminal learning, which is the thing with the owls from the Wine 7 paper. Also, yeah, a paper saying a Wine 7 also is a very good indication it's going to be a good paper.
Yeah.
We read that one on some previous reading group. Like if someone hasn't, they can go watch it on YouTube if they care. There's probably better explanations of it though. But
you should maybe zoom for the stream more.
Yeah. Okay. Like this.
Yeah. Let's see in the delay stream. I think that should be good.
Also, I can remove this thing.
Yeah. Okay.
Okay. So what is this thing about? Let's see. As usual, yeah, I haven't tried it yet, but I plan to go through it now. And if some people have already read it and have takes or want to explain, feel free to do that. But otherwise, we'll be going through it together here. Okay, so it remains poorly understood how data vote without semantic meaning can transfer specific semantic tracks. Yeah, so there is this thing for people who don't know about the other paper where you fine-tune a model to have some preference like liking owls, and then you make it write something like write a list of numbers, like a long list of numbers. And for some reason, when you train other models, especially, other copies of the same base model, on the numbers or whatever, it transmits the likes for owls to the other model. Like, there is some numbers that look normal, and for whatever reason that we don't really understand, just convince the other paper to the other model to like owls when you fine tune it on them, even though there is no obvious reason for it. And there were some hypotheses on the original paper, and we had some takes when we read it on the review. I don't remember even that much, but it seems to be about trying to use Mech Interp to explain how it works, and the answer seems to be something about the steering vectors. But
all
yeah.
you need.
Yeah, it seems Steve a lot of this interesting question. How much the fact that there is a lot of results about steering vectors explaining things is because a lot of things are actually explained by steering vectors versus steering vector is easier to find things that are explainable by steering vectors than some more complicated thing. Or a third possibility, which is the actual way this works is something that's not like a steering vector, but it's something more like some manifold thing, but is approximated by taking a steering vector, kind of like the previous Good Fire paper where they tiled manifolds with linear probes and that approximated them.
I think even manifolds are approximation though, but yeah, I see it. Maybe.
Yeah, like I mean, the other thing is not even manifold, it's some more complicated, non-linear thing, but yeah. I mean, maybe it's well approximated manifolds, we don't know.
Yeah.
I think more complicated thing might not be as well approximated by linear probes, and like the fact that sparse encoders kind of work and linear probes work might tell you something about what shapes could be. Oh, also, sorry, I see that there are people posting on chat. I was not looking at it, sorry. Oh no, just you posting a link to the original paper, and Deckard posting. Stream betas. Oh. Stream betas no corresponde a $1 per day across a place per way space. I'm so. I'm confused why Deckard, I'm confused why you are talking about one-dimensional Laura. Or maybe is it on the thread or that you posted or something? No.
Yeah, they talk about Laura in the paper.
Okay. Yeah, I guess we'll see that.
Yeah, I mean it edits the weight, but the editing the weights shapes the activation. So
Okay, so they are training the model to change the. So you mean the paper is actually not doing a steering vector? I mean, they say steering vectors here, but I guess. Okay, so they talk about.
Isn't there some equivalence though between
Steering vector distillation. Okay, so steering vector.
Approximated biased.
What do you say? Do you have accidentally open mic? I don't know. Do you say something Shrivastava?
Oh, sorry, nothing.
Okay.
Mic was open on accident.
Okay, so the thing they are calling here steering vector distillation is just training a 1D LoRa then, right?
Yeah, I don't know. Let's see.
We'll see. Okay. In this work, we show the subliminal. Yeah, because the paper is about. Right, the paper is not about. Like, the original thing is not steering, right? The original thing is changing the. You fine tune the model. So. But yeah, it's still. Okay, you could call both things. Even if you couldn't call it a steering vector, you could call both things having a one-dimensional. Adding a one-dimensional vector to the activations. Well,
Yeah.
one-dimensional, well, it's one, not exactly one-dimensional in that depends on what you call one-dimensional. Like it's one-dimensional, but not necessarily on the space of the weights or whatever.
single direction, but it's has dimensions like the activation space, yeah.
I think there are geometry words for it with the manifold about like ambient dimension is bigger than the.
Well, the manifold hypothesis is the word for it. I forgot as well.
Yeah, there was
Internal.
some.
I think. Wait. Low dimension latent manifold inside high dimension space. Yes, latent.
Yeah. Okay. So. So yeah, they find that the 3D system problems approximation by steering vector, and that the student behavior is driven by learner array vector or their fine tuning. Okay, so they are saying that when you train the model, like you have some model where you tell it to that it likes owls, and that's equivalent to just well approximated by making some specific steering vector for owls and generating text for that. Based on that, is like the numbers somehow have the steering vector embedded on them, even though they don't seem to have anything to do with owls, and that makes the model like when you fine tune it on them, that somehow transmits the steering vector to the actual model. And they are saying that if you have a prompt that is not well approximated by the steering vector, it doesn't work. It's interesting. I would be interested in see if there is some counterexample to that. If you can't find something that can be learned, and but is like that is transmitted, but is not a steering vector. But yeah, although I think it depends on like how you train exactly. But yeah, I was thinking of like if you train with LoRa or not.
I mean, systems that are not well approximated by steering vectors are not subliminal learned. I mean, I think you couldn't get the Golden Gate Bridge like behavior.
Why not? It might be a Golden Gate Bridge steering vector. In fact, if it was on a sparse autoencoder, it should work.
But you would have to explicitly prompt like Claude or to like be confused when you put it in conversation everywhere and stuff like this. I think it's
so there is no nice way of prompting Claude to, even though it's a single vector, there is no nice prompt that puts a steering vector on all possible tokens or whatever, like the you do with Claude, whatever. Okay, I think I understand what you are saying.
Yeah, I think there is more than just that, but yeah.
But I was thinking counterexamples where of things where you can in fact subliminal, if there is any, you can find any counterexamples of things that can be subliminally learned but are not equivalent to strong steering vector, because maybe that's where the interesting stuff that breaks the theory is, or maybe perhaps everything is just steering vectors.
Yeah, I hope so. It's manifold, but yeah, or
I mean, I don't think you could distinguish that. Like if it's some manifold thing, it will still work with your steering vector, right? As long as you put the steering right and land inside the right part of the manifold.
You have to change the geometry so that the path that's curved becomes a straight path in the change the geometry, like I guess you could say.
numbers are probably like for the multiple things we know that numbers are usually or weights days of the week or whatever are represented for a lot of things in ways where they are on some manifold thing where the I don't know the numbers sit on a spiral or whatever or some curve and manifold thing and the thing is if you but it's if you make a model that likes the number 3, that might still look like the steering vector in the 3 direction by plus some talk about this direction or whatever. But that that will still work with the steering vector, right? Because each number is a even if the different features are organized in a way that there is some geometry to it, each feature is still a single point in a single direction in the space in that model. But
yeah, you can steer each feature.
but you could imagine
you lose
other ways that the thing could work. Whether features could work. It just seems they rarely don't. But maybe there are some counterexamples.
Yeah, if you just steer linearly the different parts of the circle.
Voy a demostrar esta implementación sobre semantic and random vectors. Adding a semantic vector to model activations. Can both model independent and model specific. Effects on the behavior, so generated. You can also explain which way we are learning those no transfer within models. The activity of motivation in language models. Activation gains on steer data are small but consistent component about the steering direction and non-adaptive motivation display allowing their trends to dominate. I see. So, yes, this wouldn't happen with with vanilla grain descent, for example.
What exactly you mean?
Here, the last thing on the abstract.
Are necessary. Adaptive optimizers are necessary. Huh.
Yeah. Step never learning. This tells me that you are going to find like the more problematic thing will be some subliminal learning that works through models, and that for that there needs to be some relationship between two things that appears on different models. Like you have some steering vector that for some semantic thing that has some component that doesn't look semantic to humans, but all different models still learn it. And I wonder if that's a thing, or is just not the case, that just doesn't happen. I mean, a dumb example, the example of this is if humans didn't know, like it can be some weird side effect of the schedule, or it could be something that humans usually don't know. Like a toy example would be if humans didn't know how to decode, I don't know, ROT 13 or something like that. This kind of dumb example. You could imagine models writing these weird groups of letters and they somehow transmit the thing, but in the reality it's just because the group of letters actually do make sense. They're just some encoding that the models know.
Yeah.
You can make a less than example where it's some, especially now that the models are getting better ones, some novel math thing that makes two things related that you must don't know they are related or something.
I have a question. For the Adam results in this paper, like the original Owen Evans paper, I didn't think it used Adam, it used plain SGD, and I think he tweeted about it recently as well. Any ideas about why they came to the conclusion that Adam is needed for subliminal learning? Similarly, I think there was another paper that talked about LoRa being needed for subliminal learning. Any ideas about why these results when the original paper didn't have those?
No idea. So the original paper didn't use Adam, are you saying then?
Yeah, like Owen Evans posted on Twitter saying that the original paper was just a full fine tune using plain STD, no Adam.
Oh. Yeah, I'm confused about that then. I guess we can get to that part later and see why why this paper thought that, but it feels a bit silly that they didn't check. Uh, like they made this paper and said this and they didn't check the original paper.
Yeah. Or maybe they do some special case here. Not sure, yeah.
Yeah, I think we can discuss it later in the paper.
Yeah, I guess we'll get there while reading the paper. Anyway, so this is distillation. I mean, it's not. Yeah, here think of distillation, but it's not the only like the models. Also, the internet is also full of model text that it probably goes into the models these days a lot. Transference, yeah, and this is just the typical thing saying this is the previous work, this is the stuff. Yeah, we don't really understand this and all that. System per scatter stream because, ha. They take a difference of activations to get the teacher prompt. Inventory is also existing in the student. I wonder how this paper we already saying like after the yeah, but by the way, yeah, Usagi, you said most of the year on the chat for the thing. The problem is that, as I said earlier, like most of the year are probably represented as a circle for a lot of things, but each month is still a direction. So you wouldn't, if you did this kind of experiment, it will still work the same, and you wouldn't notice anything about how the months are actually a circle.
Sorry, I don't understand. What do you mean?
So I'm saying that, like, if you make like the months of the year are represented in a circle, right? But if you each month, like the representation of each month is still a direction, right? Or like approximately a direction. So you could, if you, for example, try to make a model like some month or something, you will still find some steering vector that points toward the representation of that month, and you wouldn't notice any, like it will just work for this kind of thing, probably.
Oh, okay. Yeah, maybe. But I was just answering his question where, like,
Yeah,
future
yeah.
which is not represented linearly. Yeah.
Learning this steering vector. Okay, so uh, this is the thing we were talking about earlier. We find that playing a stochastic gradient descent finds first instant the bit teacher. We trace the smaller parameters with disproportionality gradients. Hmm. Hmm. Yeah, I don't understand why this contradicts the fact that seems to just work according to Wayne Evans.
Exactly.
I don't know.
You find that SDG fails to install teacher.
Hey, okay, do we want to see if they can, like, maybe someone should take the original example of the original paper, if it has code, preferably like just the same code, and run the experiment from this paper.
There should be more research into why Agam works. Also from a Mech Interp angle.
And I mean,
Same
this
for
is a
Neel.
small model. Maybe I could just run this experiment. Well, maybe I can't really fine tune it. I was thinking if I could run it on my own PC, but I could spend a few dollars or something and try
I think
this.
they mentioned why Adam works. I think they mentioned that it uh, clamps the very high, like out of distribution or over, like very out of the distribution gradients, and it only
Yeah,
does a smaller gradient bit, so it
but
smooths out the.
Implicit normalization.
yeah, but why the very high? Yeah, they explained here, but like my question is why does the okay. The Becari saying is not that black and white works does not work. It seems that it works on almost. So yeah, I guess my question is when it works and when it doesn't, because clearly it works on the whenever says it works on MNIST
Why
with
is it different
SCG.
across models?
Yeah.
What is this alchemy?
Like
That's not how it
why,
should work.
like if it's this, why maybe there's something on this paper that explains a bit more.
Why does LoRa work and full fine tuning just doesn't work at all for all the optimizers? What? I guess because it it struggles to localize it or something. I don't know.
Another thing that's different is that here they are talking about LoRa, and the other thing is just by Ninja SCD on normal. Oh.
yesterday with Alpha we figured out this nice sentence that how was it? Most techniques don't work. Even smaller fraction works partially, and like just 0.1% works a lot, and that's what you mostly see in papers. And yeah, and that's so weird. Like a power law for things working basically in all of ML research.
Yeah.
Like this makes me wonder if this worked on one model, for some reason doesn't work on another model. Like
I feel like it probably works on
this is
all
so
models. You just need the right,
yeah, but like
setup.
the interaction is so inconsistent when you look at the Descartes. Like full fine-tuning stochastic gradient descent on Olmo works, full fine-tuning Adam doesn't, LoRa SDG doesn't. So you have to have this combination of full fine-tuning SDG. You cannot switch it for LoRa, just one part. You cannot switch one part just for Adam. They're coupled in some way. Like what? What is the explanation behind this? Or is this just noise? Or
I
is
mean,
there
it's
some
probably.
confounding
I think
variables?
it's.
Like,
Yeah.
is it initialization dependent?
It's probably something. I think maybe you can find it something that is a bit random, but there is something about like it's going to be some fact about the geometry of the activations on the model and like how because like how the how the random number activations relate to something completely unrelated doesn't have to be, to a steady vector in something completely activation. Doesn't could be just random or like depend on maybe even with the same setup and everything, you different initialization gets you different positions, right? Where there is the where for some things are undetermined by the data because there is a lot of ways you could organize the vectors where you do have need some vectors are correlated or anti-correlated and so you need to put them closer or more separated or whatever, but some other activations could be in a lot of different relationships to each other because they don't have much to do. And here you are trying to find something where it's something like number that doesn't have anything to do with the original thing, which is owls or whatever. So maybe just pretty random and different models. And like depending on what that's like, maybe you have, for example, maybe in some models you do have when you do the number activations, you have some large gradients dominate the updates, and in other cases you don't.
Yeah.
Maybe there is something interesting about models you can figure out for this. I just don't know what.
I wanna isolate all the confounds, which is almost impossible. Yeah.
Okay. But
like
maybe
this
there's
stresses
something.
me because it is breaking the dream of having general theories when you have inconsistent behavior across these implementations.
Oh, but
yeah.
maybe not. You want the general theories. The general theory has to be able to explain this in that, and maybe you find something nice about the general theory. Like the general theory says saying something like, if the model has does this or this characteristic, it will react to this way to this steering vector or whatever. Right?
Yeah.
You can see
find the variables.
if you want to find the theory, you need to find the signal on the things that look like noise, like this. And some of them will just be noise, but still your theory should explain which things are noise and why.
Yeah, true.
Maybe it has a bit to do with I mean, not maybe, but generally how much it distorts the column and row spaces of different components slash their subspaces, right? And so maybe with lore, just based off of the way it's approached, you typically do some distortion of the column and row spaces, and I guess the null spaces as well too, of different components. So maybe with different like staring vectors or different types of adapters, you have a little bit more coupling between components and less noise. And then with other ones, you have less coupling and more noise, if I guess you were to look at the singular values. But this is just like what my intuition is telling me that might be the case.
Maybe. I guess I want to see. I want to get to the part of paper where they look at that and like, is it like the plot that we have earlier, is that for like a single a single steering vector, or for average of a lot of them? I mean, I guess we'll get there, because maybe it changes on different steering vectors, or maybe it's for a single model. Like for each model, some things work. The guy is saying that anytime subliminal learning works, you can break it by changing any attribute. Which is, yeah, kind of. I guess a case where you wouldn't. My take on this. Well, also. Oh, nice. Nice. The consensus has run many experiments. But is this? Is that like on the same model, or like if you change the prompt, that also changes what helps and what breaks the thing? So like, let's say you are. Never mind. That's you change the trait. It's I want the first sample, so never mind. Well, so like, I guess my question is still like, inside the, like, if you keep like, are there any trends on like which, like, on different models, I don't know, changing the date, like changing that there are some things that break the thing more often with different traits on the same model than in other models, or does it seem pretty random? Maybe people haven't done enough. Huh. I see. Does it become like, does it become bigger, more effective, like with the scale then, in general? Okay. For some reason we don't understand 14p is just is that just on Quen, or
What?
also okay. Yeah, okay. I see.
What? Isolate the confounding variables, mission impossible.
Yeah, I guess that makes sense. That would make sense if it's one of the variables is it's something out the steering vector, and just prompting the model on the small ones doesn't actually steer the model enough. Like, they just don't understand the instruction and don't follow it much. I don't know, maybe telling the smallest model that they like owls doesn't actually make them answer coherently with that on the next prompts. So it doesn't. Yeah. It's still weird that that kind of information is something where you will expect to just get better with size, and but apparently not. But I guess maybe maybe when the models become bigger, there is some other reason why it works worse that becomes increasingly more important. And 14p is just where, at least for Quern, is when that's happening. But maybe I'm just, maybe it's just kind of random or depends on a lot of other things that change between that Quen and other models. And it's just not, I don't know. Oh, cool. Is this also from this paper or?
Just brute force possible combination.
Okay, nice.
That will work.
Subliminal is a lore artifact. But I mean, I'm going for the title that seems like Hawaiian Severs is also saying that paper is wrong because it worked on his seminal thing with. People keep saying subliminal errors because this reason, and then turns out that it isn't. I guess that makes sense if subliminal learning depends on is very brittle and depends a lot of things. I guess I can see how someone can find on a paper that they ask LoRa and it breaks. But turns out if they had changed some other variable that would have make it work without LoRa. I kind of expect there will be some cases where it seems like there is something where it's not random and it just kind of works more consistently at least but it will turn out that there is some secret relationship between it's not actually non-semantic and there is some secret relationship between the thing you thought, like maybe the numbers are encoding something, and I guess you could catch that kind of thing by finding that it's consistent between different configurations. You can catch models actually sending secret messages to each other that way. Also, people are talking on the chat, by the way. I guess I'll. It's not showing up on the video right now, but people can just go later to the chat and read it if people are watching the video. If they're interested. Yeah, I guess what ends up happening is that people come up with some theory and then they do the sweeps, and it's just that people keep up coming with wrong theories and not doing providential switch to realize that it still works in some other thing. I wonder what happened with the subliminal learning solar artifact, for example, people for them to not notice that is apparently not. Nice. Okay. Okay, so I do the steering. Okay, touch and steering vectors. Yeah, so they just take the difference in activations. Right. And the activation similarity, they do cosine similarity between fine tuning induction shift in the student stream. So I guess, yeah, they just take the activations of the student and the activation of the original and take the difference on the same prompt probably, and they take the difference. Average of cursor layers, yeah. Okay, so as I mentioned, they measure the empirical activation similarity on killing student train on random sequences on a neural system prompt. Yeah, neural system prompt. Makes sense as a baseline. So when you train more, the cosine similarity between the difference in activations to the teacher goes up, which is, I guess, the main thing. It's 0 point something for something, but like high, like those numbers are high on like space with a lot of dimensions. Like if two vectors have high, non-trivial cosine similarity, they are probably pretty related. Yeah. So anyway, anyone else does have has any take or anything to say or something about the paper so far?
Which layer is this coming from? Do you know?
Good question. First, this in Appendix A. Not this the prompt. I shall search for layer. Oh, here, 23. For when, 20, like in the middle-ish, well, towards the start, I guess. Huh. They applied to all layers here for some reason. I don't know why, but Yeah, so if you're still with the student vector direct, like the vector director, it just works. Many game mysteries. So they are claiming that the yeah. Our representation is systematic limitations to learning doesn't produce a behavior change. Yeah. I guess that's something that you could test this by finding like some concept that happens to by chance be represented similarly in two different models, and see if it works, if they can transmit it. I know how like that it let them more dimensions the harder it is for two things to represent the same. There are a lot of there are a lot of concepts, but I don't think it scales that way because the dimension scale works. Well, I don't know. Maybe it works. There are a lot of concepts, so. People are earning a living. Still about difference time to consume errors that we can predict how well the train will transfer difference time. Yeah, maybe. Okay, so maybe the quern thing. Maybe you can find some relationship in which models have more like in which models subliminal learning is strongest by in which models steering different traits will work more or better, better or worse. But it's probably more complicated than that. I guess maybe
Cross-model transfer.
like there is an effect on that, like bigger models are better at that, but bigger models are also more prone to like that are separate, are bigger, so they separate the numbers more than from the owls or whatever. So it's less likely that you have spurious correlations or whatever with the activations. No, España es muy claro, pero. Like this. Yeah. So they're trying to steer with steering vectors from one model into the other, right?
How do they define generated data that is non-semantic?
Where is that?
In the abstract is generated data that is non-semantic and transmit a vector with semantic effects.
They mean that it's just generating numbers, for example.
Okay,
That
it's
don't
just
mean anything.
gibberish. I
Yes.
see.
And like if it was semantic, I'd expect like if it had some meaning that other models can understand, and it's not some gibberish that happens to have some direction with it, I will expect this to work consistently.
I see.
Then it will just be normal generalization.
Hmm.
But I mean, we'll fail in some cases where normalization fails, but.
They try steering with the steering vectors.
We shall see that alpha is now called a quadrillion parameters.
Yeah. We yesterday I found a paper that was saying like 10, but this was in response to this.
10 to the 15.
Yeah, 10. I think it was 20 quadrillion parameters are optimal LMs given existing data, but I think RL has potential for infinite data. So.
Well, can you link that paper?
I can find it in the yesterday's 17 hours call.
Well, you're not gonna, there's a lot of backlog.
Yeah.
You're better off remembering the title and searching.
It's just taking like the chinchilla escalinos or whatever and just extrapolating.
But I think with chinchilla you get a much lower result, don't you? Like for optimal number of parameters.
Yes, but I don't think maybe it's not like the optimal. Like the chinchilla number is the optimal for if you are limited by compute and you can increase the data. Like if you have a fixed data, there is like some. But I think the chinchilla thing is like some. It's not a hard bound. It's just some. Of like it's just an asymptote. But I don't know.
So Bernie, you're saying there's no data problem. We can scale up to what is it, 10 or 20 quadrillion and it's fine?
RL agents that are connected to the world or arbitrary simulations potentially just generate infinite data.
I just need to know because I have a quadrillion parameter network and I'm wondering if I'm gonna run out of data when I train it.
Billion, not even billion.
I think data is not going to be your problem there.
Did you steal Elon Musk Solus or something?
How are you running it? Are you only running parts of it at a time? Is it like the quadrillions for the huge mixture of experts?
I mean, you
think
could
it's
train
wrong.
it just very,
Or like, are
very,
you like running
very
this with like
slowly.
some like black magic with like kernels where you're able to, I guess, run them all perfectly efficiently and everything?
If you're really dedicated, you could run it manually on pen and paper.
Yes.
I guess he's. Are you doing a pen and paper?
Just one inference for the path would take longer than the age of the universe. Yeah. Subliminal learning.
Are you gonna link the paper, or wait? Did you already?
Oh
Yeah,
yeah,
Bernie, I was like skimming the
pre-training under
paper.
infinite compute.
What are low rank? What does low rank mean for the behaviors?
So, well, do you know what LoRa? Okay. So when you fine tune an LLM, it is very it is very costly. So what people find is that if you approximate the weights using linear algebra magic, that's what LoRa does. Then you just train the approximated weights, and
I think
you
it's
get
just
the same performance for that.
isn't it just you train the model but you only modifying like some low rank matrix?
Yes, low rank matrix. That's what LoRa means, yeah.
Yeah, so
so
they're
it's
just
just
saying that it's able to
matrix
be
with low
found on
loads.
LoRa, right?
Hmm?
Yeah,
Sorry?
they just specified it's able to be found on LoRa, but what's the implications of this?
What are you talking? Do you mean
I don't think there's a difference. So I guess high rank are just like the ones that don't show up in LoRa and require more like full fine tuning. But I don't really notice. Is there any like difference between low and high rank in the context of like
So,
understanding behaviors? Because
low
like I
rank
feel like
just means you have few dimensions. Like rank 1 is just like a steering the training version of a steering vector, and high rank in the with enough high rank becomes like training the model normally.
yes.
But I'm confused. I think I missed like the start of your thing. I'm confused the context of why.
Oh
I'm
yeah.
about LoRa.
So if you could see like the low like, let me get up the part of it. It was like on section like 4, I think.
Okay.
Uh,
Yeah, I should probably go back to the paper.
yeah, they were talking about. They talk about how the subliminal learning works in this, and then in the middle of it, they then talk about how it's a low rank.
Oh, but here on low rank, they mean, I think when they talk about low rank, they also just mean it's a steering vector that is like one dimension or something. But I'm not sure.
Yeah, 6.2 says it occurs most readily under LoRa fine tuning. So I guess it happens more often if you LoRa fine tune it instead of using an optimizer.
Uh,
I wonder why it appears more with LoRa but not with simple gradient descent.
in all three
I feel like this
cases,
is more of a symptom. This might be a symptom of LoRa and not necessarily
more readily under LoRa training. Okay, so they say this, but then it
talks about how simple gradient descent does not show it. So, or did we
But
just
then,
figure out that it
Wine
just
7 says that it does show on simple gradient descent, and for what Decker says is just kind of random in that sometimes you change the other things and it breaks, and sometimes it works with higher LoRa ranks, and sometimes it doesn't, and it's like not as clean as it doesn't work with LoRa. Also, I think Decker had to leave.
No. It says it works with LoRa, but they found it not working with non-LoRa. Simple gradient descent.
They on Olmo there's one graph where it works. full supervised fine tuning on Olmo works.
Yeah, but I'm curious. Like, I feel like it's pretty easy to disprove the idea that they does not occur on simple gradient descent.
Well,
Does not exhibit.
Wayne Evans says that he tried on simple gradient descent and it works, so it's not true. But maybe it works
I mean, like,
more often with LoRa or something.
I mean, seeing if it like transfers the training directions, because we already know this premise is false. So that in that case, if this premise is false, does the steering vectors translate to like supervised fine tuning? Because they mostly looked at LoRa, I assume.
Bernie,
Yeah.
I'm looking at the paper and I can't find the thing.
Huh.
Where does it say 10 quadrillion?
I think he was talking about your username. That's the thing.
No, he was talking about the optimal number of parameters for our given data situation.
I don't know. I just read the Twitter thread, so it may be hallucination.
The Twitter hallucination.
Also, by the way,
yeah,
they like I'm gonna repost what Descartes said here. Renaming group. Okay, if you look at this graph, wait, wrong channel. Reading group.
I'm assuming from this paper they mostly looked like LoRa for like the appearance of the training, because they looked at mostly like models like Quen and Llama, but Olmo clearly has it appear in simple gradient descent, and you can see it from the results there, I guess.
Yeah, this is so weird. Like,
so I guess it might be model
Olmo,
distinction. Actually, it maybe like Olmo like has some property where like the LoRa fine tuning is more similar to supervised fine tuning.
Shame that we only have we have everything about the Olmo, but we don't have like the training data and all that for all the other models, because otherwise we could if we have two models that differ on this.
Yeah, I feel like that might be an interesting project. I might see like.
I guess we also have the details for like the.
Bhatia.
Yeah, we have the Eleuther one. We also have the Eleuther one too.
Yeah, the PCS. So
maybe
I'm gonna compare.
If PCS has this property. If PCS also has this property, it might indicate that like the more pure open models have LoRa adapters that are more accurate to the full fine tuning.
I mean, you could check something like. No, I was thinking more. Okay, so on those models you have the training data and all that, and you can run experiments like training on them or some data. Maybe someone can find some way of predicting from the training data for the model or something what makes this change, like what makes the subliminal learning work in some cases on other models. But
no, it's not a question of subliminal learning work. Yeah, I guess it's a question of subliminal learning working. I'm curious what makes subliminal learning fail. I think that might be an interesting question to explore. And when does it work? My current gut instinct of when it fails is like you try like you tell like somebody to you tell like a cat to fly, right? The cat can't fly, so it just falls on the ground. So maybe it's like an inability issue.
Okay, so this paper basically claims that that when it doesn't work, it's because it's a big thing where it doesn't work is vectors where like prompts where there is no steering vector that you get from the prompt that has the effect that they want in the model.
Yeah, so it's an inability. They have a similar. I'm gonna go try testing this, because if I could figure out an example of a direction that works for steering but not with subliminal learning, that could be an easy. Never mind. It's like gonna be like a procrastination. It's gonna be like if I procrastinate too long.
Give me the learning. Okay, so Non stiamo spend time, don't get Subliminal learn. Ha. Okay. No. Concurrent work. Okay, so this is more of the case stuff. Concurrent work has shown that SCD can induce subliminal learning with parameter tuning, but can be able to replicate using their setting. What?
What did you say? SGG can induce with hyperparameter tuning.
But we can have not been able to replicate this using their setting. I'm confused about that, but okay.
Replication crisis. Whew.
I get the feeling that the whole this is a mess.
lot.
The
That
whole
one needs some replication crisis.
there is a subliminal learning replication crisis.
Yep.
I feel like
Actually,
subliminal learning might be the one field where actually straight up there might be a replication crisis with
it is. ML is very much infused by replication crisis in general.
Yeah.
Yeah.
So I feel like
actually subliminal learning is
I wonder if in this case, like, is the model rejecting this? Could the model reject subliminal learning? That's also a question. If it's just a steering vector, could the model reject? Could the model just not update on the steering vector?
So like you trying to maybe set up, you mean if you like, I don't know, try to train cloth with some subliminal vector that is going to make it want to, I don't know, kill people.
Reject everything, every fine-tuning direction. Will it be resistant to like normal fine-tuning and subliminal?
I don't know. I guess the thing is, it's hard to get something like that because if you want to do prompts, it's already going to say no. But I guess you could get some model that's like some base model, and you have some fine-tuned model to have some safety guardrails or whatever. But yeah, I don't know. My impression is it will work anyway. I don't think models can do that kind of gradient hacking, even without it. Probably won't even realize that it's... maybe. I guess maybe if you have some model that... you know, if you have some model that, I don't know, refuses to talk about biology or whatever, and you... show it some from the same model families. You show it some subliminal learning numbers that have a steering vector, encoding a steering vector for that thing. It will react to the numbers as if they are bad or something. They will probably trigger the. If it was something like this, they might trigger the. Like if you are on when you were on Fable before they remove it. If they are doing something like to change to opposite or something like do a probe on the activations, maybe they will trigger for the numbers too.
If they cannot replicate it with the same setting, maybe the confounding variable is determinism, non-determinism of initial seeds or hashing or something in Python.
Okay, so this related work, discussions, framework for Subliminal. So this paper has a theory about stealing vectors, but still horizontal coming Subliminal learned. Yeah, that's nice. This still doesn't explain a lot of why, except very vaguely, about why it works sometimes and why it doesn't. Like it works, it tries to explain the prompt difference, but not the LoRa versus versus different models versus whatever. Effects do not follow code for level in all tokens. For Quen, Admin student does not completely recover the chat affinity induced by LoRa fine tuning. Okay, yeah, that makes sense. It's a mess. Avoiding distillation does not fully reverse the effect, so it is more complicated than this. We don't claim that Subliminal is actively steered by steering vector distillation, so it's not all steering vectors, unless it's actually steering manifolds or something, but yeah. This is video for Senthooran to show how data without semantic meaning can nevertheless. Yeah, but that's the original paper, right? The central claim is not that. The central claim is the steering vector thing, so I'm confused by this thing. We all study teachers created by system prompts and have limited data points. Very coordinated tips is necessary to install each student. We don't have principal explanation of this. And it doesn't seem to be true, which is the funny thing. Or we find that Gemma script weaker Subliminal limit that Quen's set model Subliminal learning. Yes, apparently this was already known. Find Subliminal learning is more sensitive under low run training with optimus was not crowded at all. Of course, is that which one is? Okay, so there is this Nature paper. Oh, it's the original paper. So, okay, so they did check the original paper and are confused. In MLPs. Okay. For living. Anyway, people like feel free to like either comment or something, or if you want me to go to some specific section, I can do that and all that. I mean, you just want to listen, it's okay, but yeah. You can also write on chat like Usagi and Caleb are doing right now. Subliminal learning. Yeah. So
I wonder if subliminal learning is a steering direction. Are you able to like maybe like set the the steering coefficient with how much you're training it, or like with how steered the teacher model is? Like we know it's similar, but like it'd be interesting if like maybe like if you trained it a little bit, it's gonna like steer it like 10%.
oh wait. Uh, so the example of I was okay. Subliminal learning MLPs. Yeah, I was asking Claude and it told me about this. So here they do test the MLP thing, right? Okay, so this steering vector thing doesn't seem to work on MLPs.
Wait, what?
Yeah. Like, it doesn't explain it. We test steering vectors are responsible for subliminal learning MLPs. Specifically, we still auxiliary logics with via solid stems, keeping the weight bias for MLPs. We find that this not able to induce subliminal learning in the student, which occurs is close to random.
Wait, do they by MLPs they mean instead of LMs doing MNIST MLP classifier?
Yes, the MNIST MLP classifier. How do you do subliminal learning in MSP?
Aren't LLMs also MLPs? I guess not because it
But they
also
are.
stands for
They also have.
CKCP.
They also have attention, which I could see doing something
Yeah,
maybe.
okay.
It might be also because the MNIST thing.
No, it doesn't work.
Auxiliary logics
Man.
from the teacher.
I am having very bad feelings about this research.
This feels like a weird test on the MNIST thing. But it might be a different phenomenon that just vaguely related. Because you are not right here. It's not even different tasks, right? You just a student is still only on 3 auxiliary logics from the teacher. So it's trying to. It's doing some distillation thing that's not exactly the same kind of thing where you can have some unrelated thing and okay, so auxiliary logics might be random. I don't know. I'm not. I will have to read the original paper, but it doesn't seem obviously the same phenomenon. It might not be they say it's analogous, but it might not be analogous. Nice computer resources. Hours. You could approximate a cost on that. Anyway, anything else we should look at? So mainly, I guess my main take from this paper is maybe steering, steering vectors explain something, a bit of how this subliminal learning happens on LLM specifically, but it's kind of complicated and a mess, and we don't understand it. That seems kind of random, like whether the LoRa is required or not, whether yeah.
Just get the correct initialization hyperparameters and you're good.
I'm also curious if Wine Sevens here means, like, this calls about many ablations, if that's for the MLP. Because
so Evan said it works for MLPs, and this paper said it doesn't work for MLPs.
No, this paper. So they are saying something that could be compatible. Okay, so this paper claims that it works better with LoRa for LLMs, right? For MLPs trained on MNIST with that weird setup that might be analogous or not, they claim it's analogous, it doesn't require LoRa. What I'm not sure if Wayne Evans is also saying that he tried with LLMs without LoRa and it worked. It could be that they require LoRa on LLMs, but I think Deckard was saying that was not the case, and sometimes adding LoRa breaks, sometimes it doesn't. And sometimes you increase the LoRa rank and it becomes stronger. So, who knows? But it could be that LoRa makes it happen more on LLMs, but not on the MLPs. Because I don't know if the MLPs thing is even the same thing. But yeah, that's that. I guess. There's a bunch of appendices, but so I think it's slightly funny. I sent the thing to Opus, right? The paper to Opus to ask questions about it to find things easier. And when I just asked it, what do you think about this paper? It was slightly suspicious about the fact that that the paper is from the future, because it's June of 2026 and its training data could have been much earlier.
Oh, right, yeah.
It's like it cites other papers and that makes sense from that year. It makes sense, but
yeah, that's weird because I would expect Opus in Claude AI to have, if you're using the interface there, to like have a date in it, system prompt.
Yeah, I don't know. I think it does, but maybe just confused. I will try Fable, but they took it from us.
Yeah, US government. No more Fable for the plot.
And maybe it will come back, but only for the American.
Yeah. Someone joked that EU companies will be hiring random Americans as access to Fable.
Just marrying Americans for the Fable access.
Yeah. Rune had an interesting comment.
Anyway, anyone else wants to say something about the paper? I'd say mostly that's mostly it. Like, I mean, there's some graphs I haven't read, but yeah. So this is the thing what the Decker was saying, that where it showed that it was like Laura and Adam work the best in Quen, but work. Yeah, I guess. To be fair, seems like Laura and Adam is the best for all three models. It happens a bit for some of the others. Right.
Yeah. Laura and Adam win.
It's just for some reason almost works a bit, but it still works less than on the other thing. Yeah, it's kind of weird. I wonder if there is some architectural difference between Olmo, but it's kind of, yeah, I don't know. We will have to see also the other paper, like the other paper that the car mentioned, and other data that people have, are like, for scaling.
There's always a typo. Why do I always make memes with typos?
Just to show that you are not an LLM.
Yeah, that's true. It's handcrafted, human-made, GMO.
I mean, well, I mean, to be fair, LLMs
There's only 4 words.
Make something like typos on images. They just it's more like very blurry red letters that can be one letter or another, but yeah. I guess people are leaving. If nobody has any more takes on the paper, we could just end it here as the recording at least, and switch to the part where we just talk about random machine learning stuff all day.
Yeah.
I'm not sure how much I feel like doing that all day, but we'll see. We may take a break instead, but
Thanks.
Well, unless the Discord had last 3 days, 12 hours call. Yeah.
Yeah, I guess I look a bit more on the paper to see if there's anything interesting. I see anything interesting, but otherwise I'll just leave it here.
Yeah.
But yeah, it seems like not everything is maybe still in vectors, but it's kind of. MLPs don't seem to be about steering vectors in that setup, but I think that setup is weird, so.
Like, I would expect, if they try to do the subliminal learning on something that, works better with a manifold, then it's better to use manifolds, yeah.
Someone's gonna somehow find, from that small screenshot of my transcript, they're gonna find me.
Yeah, there'll be some pixels on it that somehow are compression artifacts that can be used to take the original screenshot, and then they'll.
But yeah, Duggar always pretends like he's the only one that knows. I guess he deals with a lot of stupid people. I don't know what what her experience is like or whatever. But I guess being a podcaster, you do deal with a lot of bullshit.
I feel like on Twitter, yeah, there is a lot of people who buzz takes on computability theory. I think that there is also people who are very confident that other people are having bad takes on computability theory, and they are the ones having bad takes. But that's another thing.
Yeah, I guess. Or if you wanna still continue this paper,
I mean, mostly not really. I think it's mostly done, right? Or like, there's some things I didn't read, but it's number data.
but it's interesting, yeah.
Kind of random that some animals are not steerable at different time.
Oh,
You did have an interesting point though, but it wasn't like it wasn't like, oh, LLMs are or are not turn complete. But the point that they're not trained to utilize their turn completeness.
I mean, that's not obvious. Like, in what sense?
Yeah, it's like it's not obvious, which is why I asked him to write it up.
Okay, I'm going to stop the. We can talk about that more, but I'm going to stop the recording unless anyone else has some take on this paper.
Oh god,
Okay.
Duggar's gonna find this recording.
Okay.
Ban me.